nerves coming off the brain. Those are called cranial nerves, and there are nerves coming off the spine. Those are called spinal nerves. And we'll start with the cranial nerves. There are 12 pairs of cranial nerves. Two attached to the forebrain, the rest are within the brain stem. Most of these are mixed nerves, but there are two pairs that are purely sensory. They are numbered 1 through 12. They are named, and those numbers go from rostral to caudal, so front to back. And there are a number of these mnemonic phrases that help you to remember the names of these cranial nerves, because not only are they numbered, they do have some very informative, although it may be interesting, names. Some of these include the O on occasion, our trusty truck acts funny, very good vehicle anyhow. And another one is O, once one takes the anatomy final, very good vacations are heavenly. As a matter of fact, if you go on the internet and search for these mnemonic devices, you are liable to find some that are not to be shared in mixed company, but they may help you better remember. They may make more an impressionable memory upon you. So they are the olfactory nerve, optic nerve, oculomotor nerve, trochlear nerve, trigeminal nerve, abducens, facial, vestibulo-ocular, glossopharyngeal, vagus, accessory, and hypoglossal nerve. Look at those here. We see their functions are listed, and we're going to go through each one as we will make our way through this. So the olfactory nerve is a sensory nerve of smell. It runs from the nasal mucosa to the olfactory bulbs, passes through the cribriform plate within the ethmoid bone. Its fibers are going to synapse in the olfactory bulbs, and its pathway terminates in the primary olfactory cortex. It is one of the purely sensory, and that sensory is of smell, olfaction, function. The second one is the optic nerve. The optic nerves arise from the retina, so this really isn't technically outside the central nervous system. It's more of a brain tract than a nerve like the others, but we still refer to it as the optic nerve, and it's part of the peripheral nerves. It passes through the optic canals where it converges, and parts of it cross over, and that is known as the optic chiasma. And when we talk about visual fields, that will become more important. Those optic tracts are going to continue to the thalamus, and then they will have synapses with other neurons. The optic radiation fibers are going to run to the occipital cortex, in the visual region of the occipital cortex, and it is also purely sensory. It is only carrying visual information. The oculomotor nerves are fibers that extend from the ventral midbrain through the superior orbital fissures to 4 of the 6 extrinsic eye muscles. It's going to be used in raising eyelids, directing eyeball, and constricting the iris. That's part of the parasympathetic autonomic nervous system, and controlling the shape of a lens for accommodating the lens. The trochlear nerve, number 4, goes from the dorsal midbrain into the orbits through the superior orbital fissure and innervates the superior oblique muscle, which is one of the extrinsic eye muscles. And it's primarily a motor nerve that directs the eyeball. The trigeminal nerves, number 5, are the largest of the cranial nerves. Their fibers extend from the pons to the face, and it's divided into 3 divisions, hence tri. Ophthalmic, which is number 1, passes through the superior orbital fissure. The maxillary, V2, passes through the foramen rotundum, and the mandibular, V3, passes through the foramen ovale. They have sensory impulses from the various areas of the face for 1 and 2, and motor fibers for chewing or mastication in number 3. The abducens, number 6, fibers are inferior to the pons, enter the orbits through the superior orbital fissures. It is primarily a motor nerve. It innervates the lateral rectus muscle, which again is one of those 6 extrinsic eye muscles to move the eye. The 7th are the facial nerves. Their fibers are from the pons, travel through the internal acoustic meatus, and emerge in the stylomastoid foramina to the lateral aspect of the face, side of the face. It's chief motor nerves of the face with 5 major branches, and the motor functions would include facial expression, parasympathetic impulses to lacrimal and salivary glands. It also has sensory taste function for the anterior 2/3 of the tongue. And this is a nice little way to remember where the facial nerves go. Number 8 is the vestibulo-ocular nerves. They're fibers from hearing receptors in the cochlear division and equilibrium receptors in the vestibular division. We'll talk more about those when we get into the special senses of hearing and equilibrium. They go from the inner ear through the internal acoustic meatus and enter the brainstem at the pons medulla border. They are mostly sensory function. There is a small motor component that helps to adjust the sensitivity of receptors, and we'll talk more about that when we talk about that special sense again. And this was formerly referred to as the auditory nerve, but auditory does not take into account the equilibrium, so it's been renamed. Number 9 is the glossopharyngeal nerve. Glosso refers to tongue. Pharynx we talked about or will talk about. There are fibers from the medulla that leave the skull through the jugular foramen and running to the throat. It has motor functions. It innervates part of the tongue and the pharynx for swallowing, provides parasympathetic fibers to the parotid salivary glands, but it also has sensory functions. It has fibers that take taste information and general sensory impulses from the pharynx and the back of the tongue, and impulses from the carotid chemoreceptors and baroreceptors, and those will become important when we talk about blood pressure regulation. Number 10 is the vagus nerve. The vagus nerve is one of those anatomy trivia questions because it is the only cranial nerve that leaves the head and neck region. It has fibers from the medulla that exit the skull through the jugular foramen. Most of the motor fibers are parasympathetic fibers that are regulating activities of the heart, the lungs, and our viscera, abdominal viscera. But it does have sensory fibers that carry impulses from thoracic and abdominal viscera, baroreceptors, chemoreceptors, and taste buds of the posterior part of the tongue and pharynx. Those baroreceptors detect pressure, and chemoreceptors detect chemicals. 11 is the accessory nerves. They're formed from the ventral rootlets of C1 through C5. This is part of the spinal cord, not technically part of the brain, but their rootlets pass into the cranium through through the foramen magnum. The accessory nerves then exit the skull through the jugular foramina and innervate the trapezius and sternocleidomastoid muscles. This one was formerly called the spinal accessory nerve, but now it is just the accessory nerves. Hypoglossal nerve are fibers from, and this is 12, of medulla that exit the skull through the hypoglossal canal. They innervate the extrinsic and intrinsic muscles of the tongue that contribute to swallowing, and we use them to speak. So again, here's where they originate from. I haven't gone into the testing for each one of those, but there are specific tests to help you determine the functionality of each cranial nerve. That's covered in the figures, and it's part of the lab over this section. So we have the olfactory, which is sensory only, and it does not have parasympathetic fibers. The optic, sensory only, no parasympathetic fibers. Ocular motor is motor only, but it does have parasympathetic fibers. The trochlea is motor only, it does not have parasympathetic. Trigeminal is general sensation is there, motor function is there, not parasympathetic. The abducens, motor only. Facial has all three. The vestibulo-ocular, mostly sensory, some motor. Glossopharyngeal has all three. Vagus has all three. The accessory and the hypoglossal have motor only. So the olfactory and optic nerves, the neuron cell bodies, are all located within their special sense organs. The other nerves with sensory information, that would be 5, 7, 9, and 10. Their neuron cell bodies are located in the cranial sensory ganglia. Some mixed nerves have both somatic and autonomic fibers. Motor neuron cell bodies are in the ventral gray matter of the brain stem. Some of the autonomic motor fibers are in ganglia. So if you want to remember the primary functions of the cranial nerves as either sensory, motor, or both, there is another set of mnemonic devices. Some say marry money, but my brother believes it's bad business to marry money. All right, that wraps up the cranial nerves. Next, we'll look at the spinal nerves.